Hello students. So in this lecture I'm going to teach different methods to calculate the squares of a number, right? And first method is what? By using a plus b whole square formula. We know already formula a plus b whole square, right? So a plus b whole square equal to how much? A square plus 2ab plus b square. This is the formula. Now I'm going to use this formula to calculate the squares of the number. So till 1000 also we can use it comfortably, right? So it is one method. Next method, so squares of the numbers, second method. So squares of the numbers based on, based on numbers ends with 0, numbers ends with 5. Based on numbers ends with 0 and 5. Is the second method. If you know squares of the number ends with 0 and squares of the number ends with 5, we can based on these two squares only we can find squares of all numbers. And third method is there. So squares of the numbers based on base method and converted base method, convenient base method, right? So squares of the numbers, so based on standard basis, and converted basis, standard basis and multiples of standard basis, right? So converted basis, so we learn these three methods now. After that, in next lecture we'll calculate square root of any number and perfect square numbers, right? Now first I'm taking numbers, two digit numbers I'm taking here. Single digit number squares already we know that. Suppose I'm taking, so I want to calculate 21 square, right? So I can consider b as 1 and a as 2 here. First we need to write b square value, 1 square value here. Next one, 2ab value, 2 into 2 into 1 will write. Next, a square value, 2 square value. If b is a single digit number, write all single digits, write all places as single digits except the last place, right? So now what you'll get, 1 square is 1 and 2 into 1 will get 4 and 2 square equal to 4 only. We'll get 441 as the result. Suppose I want to calculate 23 square, and here also same thing, and b square value, leftmost part is what? So we need to find unit digit value. First I'm writing 3 square value, right? B square, and 2ab value, 2 into 3 will write. Next one, a square value, 2 square will write it. If b is a single digit here, so in all places we have to write the single digit, and if extra digits are there we need to carry forward it, right? So 3 square is a 9, and here 2 2 is 4, 4 3 is 12, and 2 will write, 1 is a carry here, and 2 square is a 4, 4 plus carry 1 will get 5, will get 529. Like this we can calculate the squares of the numbers. So till thousands also we can comfortably, right? I want to calculate the 92 square on, right? How to calculate 92 square? We'll write b square value, 2 square value here, and 2ab value, right? So 2 into 9 into 2 will write, and here a square value, 9 square value will write. So 2 square is a 4, and here 2 9 is 18, 18 2 is 36, 6 will write, 3 is a carry here, 9 square is 81, 81 plus a 3 will get 84. So 8464 we can get here. So now similarly I'm taking, so 106 square value. Here we can handle this value with a 3 digit number. I can consider b as single digit number or double digit number, right? Not a problem. First here I'm taking b as single digit number and a as what, 10 I'm taking here, right? 2 digit number. Now b is a single digit number, in all places we have to write fill only one place value on one digit on, right? So 6 square 36 only here. 6 square I'm writing. So 2 into a value how much? 10, b value 6, and a square value how much? 10 square on. Just simplify. 6 square 36, 6 is the number and 3 is the carry here. And 2ab value 2 into 10 20, 26 is 120, 120 plus 3 123. Write 3 and 12 is the carry here, right? So 10 square is 100, 100 plus 2, so we'll get 112, we'll get it, right? And 106 whole square equal to how much? We'll get so 11,236 we can get it. Suppose you can take like this also, right? I'm taking 106 square here, 106 square. So here I'm taking b as a 2-digit number and a as single digit number. I can take like this also, here also. So I can write b square value 06 square and 2ab value. So 2 into 1 into 06 I'll write it, and a square value 1 square will write it. And here b is a 2-digit number, and every place we have to fill two numbers. We have to write two numbers only. 6 square 36 will get as it is, and 2 into 1 into 6 will get 12 as it is, and 1 square is 1. In this way we can write the squares of the numbers and squares of the numbers by using a plus b whole square only. And similarly I'm taking one more example. Let's consider 991 square here, right? How we can calculate it? So we can go like this also. I'm taking b as a single digit number and a is this much, right? You can take like this also. Now I'm writing, so a square value 1 square, add b square value here, b square value 1 square, and 2ab value 2 into 99 into 1, and a square value 99 square we can get it. So how much will get my here? 1 square is 1, we can write 1 as it is. If b is single digit number and every place we have to fill only one place on, right? So 2 into 99, so how much will get here? So 198 we can get. So we'll write 8 here, 19 is a carry only, and 99 square value also we can use in the same method. So 99 square we have to calculate it, right? 99 square equal to how much here? We'll get 9801 on, right? 9801 plus 19 carry, will add it here, 19 carry value. So how much will get totally here? So 9820 will get it, 98, so 20 we can get. So in this way we can find squares of the numbers. So 1 to 1000 also we can do comfortably, right? Now I'm going for second method. So squares of the numbers based on numbers ends with 0 and 1, right? Now I'm going for second type on. Second type. So already we learned before in previous classes, numbers ends with 0 and 1 also. Otherwise starting I can take normally only. So numbers ends with 0, right? 10 square we know that. So 10 into 10, which is 100 on. It is in the this format. If number ends with 1 0, its square value 1 into 2, 2 zeros only, and the leftmost part 1 is there, 1 square equal to 1 on, right? And 20 square value how much here? So 20 into 20, 400 only. We can tell in other way also normally. How? If number ends with 1 0, its square value 1 into 2, it will end with 2 zeros only. And leftmost part non-zero number is a 2, 2 square is a 4, right? We'll write 400. And 30 square also I can write it directly. 3 square is 9, 1 0 is there, after squaring we'll get 2 zeros only. So 40 square, like that squares of numbers ends with 0, we can write very easily, right? So its value equal to 1600. 50 square equal to how much? 5 square 25, 1 0 is there, after squaring it will become 2 zeros only. So in this way we can find squares of the numbers ends with 0 only comfortably. And similarly squares of numbers ends with 5 also we learned previous classes. Again check it once, right? So 15 square value, if any number ends with 5, its square value always ends with 25, right? If any number ends with 5, its square value always ends with a 25. Left rightmost part is what? Always a 25. And break your number into two parts, 5 and other than 5, right? Now left to get leftmost part, other than 5 what number is there? So that number you can multiply, it's a next number, next integer. So 1 into 2 will get to 2 only. Its value equal to 225 we can get. And 25 square also same thing. Break your number into two parts. If number ends with 5, its square always ends with a 25 only. We'll get 25. Now other than 5 what is there? Multiply that number by its next integer in the number line, right? So 2 next number is what ma? In the number line case 3 only. 2 into 3 6. 6 at 25 we can get it. If number ends with a 35, its square value how much? So if number ends with 5, its square always ends with a 25. This is the standard. Your rightmost part is always a 25 only. So here other than 5 what integer is there? Multiply that integer by its next integer value. So I can multiply by 4. 3 into 4 I can get a 12. 35 square equal to how much? 1225. In the same fashion I can find squares of any number ends with the 5, right? Suppose I'm taking 115 square value, right? So break your number into two parts, 5 and other than 5. If number ends with 5, its square always ends with a 25 only. 5 square 25 will get as it is. And what is the other than 5? 11 only, right? Multiply 11 by its next integer on the number line. So 11 12 how much here? So we'll get 132 only, right? So 115 square equal to how much? 13,225 we can get. In this way we can find squares of the numbers ends with a 5 and 0 comfortably, right? Now based on these squares, if you know these results, we can find squares of the numbers, remaining numbers, very simply, right? Very comfortably. Now how you can calculate it? So I'm taking now numbers of the form x plus 1 whole square, right? X is what? Your known number, right? X plus 1 whole square formula we know that x square will write, and here 2 into x into 1 will get to 2x value plus 1 square. Now this is the formula, x square plus 2x plus 1. Now I want 16 square value, right? How to write this one? 16 is nothing but 15 plus 1. I can write 15 plus 1 whole square. So we know 15 square value comfortably. We can write 15 square, this one, and next one here 2 into 15 into 1 will get 30 here plus 1 square equal to 1, right? 15 square 225, 225 plus 30 will get to 255, 255 plus 1 256 we can get. In this way we can find all the numbers plus 1 format numbers very easily. And here I want 11 square, right? 11 square also what? 10 plus 1 whole square I can write. So a square 11 square value, sorry 10 square value I can write here. 2ab value 2 into 10 into 1 will get a 20 here plus 1 on that. So we know 10 square value how much? 100. 100 plus a 20, 120. 120 plus 1 equal to how much? 121. And similarly, so I want a 21 square only. 21 square also same thing. So 20 plus 1 whole square I can write it. So a square value 20 square here will write 2 into a into b value 2 into 20 into 1 will get 40 plus 1 will get 20 square 400 plus 40 440 plus 1 441 on that. By using this technique, benefit is what? So we can practice oral addition, right? Oral calculations we can practice it. With practice this is a very effective method, right? And similarly I want a 26 square value, right? 26 square, so I can write a 25 plus 1 whole square value. So 25 square I know that its value how much? So 625 we can get. We can calculate this one orally, right? And 2ab value 2 into 25 into 1 will get 50 plus 1 on that. So 225 plus 50, 275, 275 plus 1 will get 625 plus 50, 675 plus 1, 676 will get the answer as 676 here. And similarly I can calculate 91 square also very comfortably. So I'm writing 90 plus 1 whole square here. So 90 square here plus 2 into a into b value 2 into 90 into 1 will get 180 plus 1 on that. So 90 square equal to how much? 9 square 81, 1 0 becomes a 2 zeros, and place 180 value plus 1 on that. So if you add them, 8100 plus 180, so what you'll get ma 8280 will get plus 1, 8281 we can get it. So like this 96 square I want to calculate it. In the same fashion we can try it. So 95 plus 1 whole square on that. So 95 plus 1 whole square, how much here? 95 square we learnt previously only. So 95 square equal to how much? We'll get 9025 on that. If square of number ends with 5, its square always ends with a 25. Multiply other part of 5 by its next integer, right? So 9 into 10 will get 90. 9025 will get, and 2ab value, 2 into 95 into 1 will get how much? We'll get a 190 only plus 1 on that. So we'll add them. How much you'll get here? So 9,000, 9,000. So here 190 plus a 25 here. We'll add them. How much you'll get? So 9,216 we can get it, right? So in this way we can calculate it is the numbers of the form x plus 1 whole square, and similarly x minus 1 whole square type of numbers also we can calculate it, right? X minus 1 whole square. So x is what? Your known number on that. So number ends with 0, 5 type of number we are taking like a x only. If we simplify, x square minus a 2x plus 1 we can get. So I want to calculate 14 square value. I know 15 value, right? 15 minus 1 whole square I can apply it, right? So 15 square 225, and 2ab value 2 into 15 into 1 will get 30 plus 1 value. So how much will get my here? We'll get 196 we can get. 225 minus a 30 value, right? So we'll get 195 will get plus 1 196. And similarly I want to find 19 square value on that. 19 square also 20 minus 1 whole square format we can assume it. Its value equal to how much? A square 20 square minus a 2 into a value 20, b value 1. So plus 1 square on that. So if you simplify, 20 square 400 minus 40 value. 400 minus 40 360. 360 plus 1 equal to how much? We'll get 361 on that. Like this, if you know one number, it's a plus one format minus one format numbers we can calculate very easily. 24 square I want, I can write it that 25 minus 1 whole square format. A square 25 square. So next one minus a 2ab value, minus a 2 into a value 25, b value 1 plus b square value 1 square will write. 25 square equal to how much? We'll get 625, and 2 into 25 will get 50 plus 1 on that. So 625 minus 50 value. So how much will get? We'll get 575 will get plus 1 will get 576 we can get. In this way, so squares of the numbers ends with what 1 or 9, 4 or 6 type of numbers we can calculate very easily, which are nothing but so x plus 1, x minus 1 type of squares we can calculate it, right? By using only two squares, we are able to calculate many squares. And similarly, numbers of the form x plus 2 or x minus 2 whole square, right? Now it will give squares of all numbers automatically, right? And here also a square. So plus or minus, plus case will take plus, minus case minus. And 2ab value, 2 into x into 2 will get 4 times of x. So plus a 2 square value will get 4 on that. This is a number. So how we can calculate it? Suppose I want to calculate 27 square value. So I can assume that 25 plus a 2 whole square on that. So a square 25 square will write it. 2ab value 2 into 25 into 2 will get a, so 2 into 25 50 into 2 100 will get plus a 2 square value equal to 4 on that. So if we simplify this one, so 25 square value how much here? We'll get 625 plus 100 value. So 725 plus 4 will get 729 on that. So I'm calculating squares of the numbers of the form x plus 2 whole square type of number. Suppose I want a 22 square value. It is also plus 2 type of number only. 20 plus 2 whole square, we'll write it. So a square how much here? 20 square only. Plus a 2ab value. 2 into 20, 40, 40 into 2, 80 will get, plus a 2 square equal to 4 only. Its value 20 square equal to how much ma? 400 plus 80, 480. 480 plus 4 will get 484 only. And similarly, suppose I want 92 square value, we can calculate in the same fashion, right? So 90 plus 2 whole square, we can assume it. So 9 square equal to how much ma? 81, 10 becomes a 2 zeros, right? Now 2ab value, 2 into 90 into 2 value will get 360, will get it, right? 92 is 180 into 2, 360. Plus a 2 square equal to 4 will get. So if you add them, how much will get ma? 8100 plus 360, 8000. So 460 plus 4, 8464 we can get it. So by keep on practicing this type of numbers, with help of numbers ends with 0 and with help of numbers ends with 5 alone, we can find squares of all category numbers, right? So it is one technique. So it is also simple technique, and we'll go for furtherly next technique, right? Numbers, squares of the numbers. So based on standard basis and converted basis, convenient basis, right? How we can calculate that particular type also, we'll see that, right? Now numbers, right? N square. Any square of a number if you want to calculate. If numbers are standard base is what? So they are the standard basis on, right? Standard basis. If numbers are very closer to standard base, 10 power n type of numbers on, right? Standard basis. So now your number which format here? Now b plus x whole square format or b minus x whole square format. Slightly more than your standard base and slightly less than your standard base on. What is your answer here? Your rightmost part value always what? Square of that extra value, right? So that extra value plus x or minus x is there, that is called extra value, surplus or deficiency value, right? So different from the base. Now how much difference from the base? That number value. And here leftmost part of your number is what? To the number we can add surplus if it is extra, right? It is less value, we can subtract the deficiency value. In this way we'll write it. Otherwise, so one more way also there. Rightmost part is what? Must square the square of the deficiency or surplus. Leftmost part value base plus or minus, right? Extra is there, plus we can do it. Less is there, we can do subtraction, right? So base plus 2 times of that surplus or 2 minus its a deficiency value. Clear, no? So in this way we can calculate the squares of the number. So very closer to your standard base one. So I'm taking 11 square now, right? So take 11 square starting. So this number is nothing but plus 1 more than your standard base, and square this surplus value, put it in the right hand side only. So 1 square will get it. Now, so to get leftmost part to the number, we can add its surplus value. It is one thing, n plus x value, right? 11 plus 1 value. How much will get? Will get 12, will get here 1 on, right? But number of zeros in the base must be equal to number of digits in the rightmost part, right? So in this way we can calculate. Otherwise, what we can do? Base plus 2 times of surplus will write when it is more than your base, right? Number is more than your base. And x square in the rightmost part on, right? So I can use this technique. 11 is what? 1 more than 10. 1 square will write here. And here base is at 10 plus 2 times of its surplus value how much? 2 on, right? So still here we are getting 121 on, right? So in this way we can calculate the squares of the numbers closer to your base one, right? Now I'm taking here again. So 94 square I want to calculate it. Now your base is what here? 100 only. Base is 100, right? Now your number is how much less than your base? 6 less, no? So we'll write minus 6 on. Now what we can do here? So square the deficiency value to get so rightmost part of your number, right? So from the number less than your deficiency to get what ma? It's the leftmost part, 94 minus 6 only. So we can get how much we'll get here. 94 minus 6 will get 88, and 6 square value will get 36 on. Here your base is 100. Number of zippers in the base equal to how much? 2. So that we need to write 2 digits in the rightmost part of your square. Now let's consider one more example to make it clear on this part. Now take 106 square value. Right? Now here your numbers are what ma? Closer to standard base 100 on, right? The 10 square na. Now your number is how much more than your standard base value? 6 more, and put plus 6 value so below the number, right? Inside the circle, right? Now and write the square of this surplus value and put it in the rightmost part of your number, right? 6 square is 36. I'm keeping in the rightmost part of the number, and make sure that your rightmost part of the number contains how many digits, how many zeros are there in the base, as many digits only we need to write it exactly, right? Now to get the leftmost part of the number, so to the number add its surplus value, right? So 106 plus 6 value will get 112, we can get it. Therefore 106 square value how much will get? So 11,236 we can get the answer on. Now we are going for next part, right? Numbers closer to n into 10 power k format numbers, right, are proportionately numbers, right? What is the meaning of it? So if I'm taking numbers which are closer to convenient base, right, not standard base, right? 21 I'm taking 21 not closer to 10, it is closer to 20 on, right? And 20 is our convenient base only. It is a proportionate base to our standard base, right? So if you multiply our standard base by some number, I can get this base form, right? Now to get 20 we need to multiply our standard base by 2 only. 10 into 2 will get a 20 on. Now 20 is our convenient base on. When compared to your convenient base, your number is how much more? We'll check it once. So 1 more on, right? And square it and put it in the rightmost part. 1 square is 1. We'll write 1. So your standard base contains only 1 0 in it. So that rightmost part exactly we have to write 1 digit on, right? Now leftmost part value how much? To the number. So we can add its surplus value 22 we can get into this proportionality multiple is there, that we need to multiply it, right? So we multiplied our standard base by 2. So multiply leftmost part by that standard base one. Multiply leftmost part by that proportionality number. What will get? 22 2 ja 44 will get, and 1 square value 1 as it is on, right? So 21 square value how much will get? 441 on. And similarly take 23 square also. Your number is how much more than your convenient base? 3 more, and square it and set in the rightmost part of your answer, right? 3 square is 9. I'm keeping 9 as it is, right? Now to get leftmost part of this particular thing, to the number we need to add its surplus value. 23 plus 3 will get a 26 on. Multiply 26 by its multiple of standard base is there. Which multiple is there? 2. We need to multiply by 2 on, right? Now what will get my here? 26 or 2 ja 52 and 9 as it is on, right? And let's consider one more thing, 32 square on. Your number, your convenient base is what? 30. Your numbers are closer to 30, not 10, right? Now 30 is what? 10, 3 times of your standard base on, right? Now 32 is how much more than 30? 2 more only, and square it and put it in the rightmost part of your answer. 2 square is 4. I can write 4 only. Why? Your standard base contains only 1 0 in it, so that we need to allow only 1 digit in the rightmost part, right? Now to get leftmost part of the number, to the number add its surplus value, right? 32 plus 2 value how much? Will get 34 only, into, so your convenient base is a 3 times of standard base. Now we have to multiply leftmost part by 3 on, right? What will get? So 34 3 ja value, 33 ja 90, 4 3 ja 12 will get, so 102 and 4 as it is on. Therefore we know that 32 square equal to how much? 1024 on. And similarly I'm taking so 53 square on, right? So now to consider here also your base value, how much? Convenient base value, I'm taking 50 only, which is, so I can take like a, so 5 times of your standard base, right? It is one way, right? If I take 5 times of your standard base, now your number is how much more than your convenient base value? 3 more on, right? And 3 square value 9 will write. Rightmost part must be contains only one digit only. Your standard base contains only 1 0 in it, right? Now to get the leftmost part of the number, what we can do? To the number we can add its surplus value, 53 plus 3, 56 will get, into 5 times 1, right? Its proportionately number is what, 5 na? So your 50 is a what, 10 or proportion in the ratio 1 is to 5 na? We know that, right? 5 is to 1, right? Multiply this number by 5 only, what will get, ma? So 56 5 ja, how much will get? 56 5 ja will get 280 will get, and 9 as it is on, right? Same thing we can handle differently also. Suppose I'm taking 53 square in the same way, but base is a 50 only. Base is a 50 only. I'm taking this 50 value, I'm writing in terms of standard base. Other base I can take it, right? It is nothing but 100 into half I can consider, right? 100 into half. In the same fashion, can you get it? Yes, we can get it. Now see that your number is how much more than your standard base, your convenient base? 3 more on. 3 square value how much? 9, and put it in the rightmost part of the number, but write it as a 0 9. Your standard base value how much? Contains a 2 zeros in it. Your rightmost part also we need to allow exactly 2 digits only. 9 I'm writing like a 2 digit number, 0 9 format on, right? Now, so to the number we can add its surplus value. 53 plus a 3 value will get 56 into its proportionality number is what, no? To get 50, 100 into half, na? We need to multiply with the half on. How much will get here? So 2 2 ja 4, 2 8 ja 16, 0 9 on. We are getting the same thing as it is only. So in this way we can calculate the squares of the number by using proportionality logic also, right? Let's consider one more number. I want here 77 square value, right? Now your convenient base value how much here? My base is what here? I can consider 70 only, which is what? 7 times of your standard base. Clear, na? 7 times of your standard base I can consider like that. Now see that your number is how much more than your convenient base value? 7 more, right? 7 more, and square this number and put it in the rightmost part, right? So 7 square is 49, but we need to write only one digit. Your standard base contains only 1 0 in it, no? Now here leftmost part of the number, to the number we can add its surplus value. So 77 plus 7 value, how much will get? So we'll get 84 on. 84 times of this value how much? We need to multiply by 7 in the leftmost part. This proportionality number is there, na? We need to multiply with that particular number. What will get finally? 7 square 49, 4 is the carry here, and 84 7 ja equal to how much, right? 84 sevens. So here 7 4 ja 28, so 7 8 ja 56 plus 2, so 58 we can get. 588 will get, plus carry 4 value, na? So what will get here? So 588 value plus 4 will get 592, we can get it, right? 5922 will get it. 72 square equal to, sorry, 77 square equal to how much we got finally? So 77 square value, this much we got it, right?